In this lesson, we're going to keep working with rational expressions, but we're going to see what happens when we multiply them together now. So, we've already seen how simplifying rational expressions involves factoring them and then writing restrictions, of course. Really, the same thing is going to happen with multiplying. The only difference is we're going to multiply the factors that are left over from our reducing together. So we're going to factor the numerators and denominators. We're going to reduce anything that's on the top with anything that's on the bottom of any of the rational expressions. And then we're going to multiply the numerators together. And I don't mean we're going to expand them. I just mean we're just going to write them. We'll keep them in factored form. And we'll do the same thing with the denominators. And, of course, we'll write the restrictions. So, again, I do need to point out that it's a little bit different for monomials than binomials or trinomials. We don't have to factor monomials. 10x is a monomial, 3y is a monomial, 6y squared is a monomial, 5 is a monomial. So those are all monomials. I can't factor those ones. When you've got something like this, really all you're going to do is reduce anything on the top with anything on the bottom. In the same way that if, say, I had 2/3 times, 3/4, I could reduce the 3's, even though they're on separate fractions, I could reduce those 3's. I could reduce 2 goes into itself once and it goes into 4 2 times. And then if I was to rewrite it, 1 times 1 on the top, 1 times 2 on the bottom, that would reduce to a half. So I can reduce something on either the numerator of either fraction with something on the denominator of either fraction. So with that in mind, actually before I do that, let's do the restriction. Anything that's going to cause a problem in either one of the denominators, I should do as a restriction. I want to do it before I reduce things. As you can see, I've only got one variable, it's the y. If y were to equal 0, that would be a problem, so that's my restriction, y can't equal 0. As I pointed out in a previous lesson, if it's a monomial like this is, then it's always just going to be whatever the variable is can't equal 0. So there's my restriction, and as for the actual reducing, well, I see that there's a 3 on the bottom and a 6 on the top, so 3 goes into both of those, and I can reduce that. Also, I see that there's a y on the bottom, which will cancel out with one of the y's on the top, so just leaving one y up there on the top. I see there's a 5 on the bottom here. I can divide that by 5, and 10 can also be divided by 5. So what I'm left with, I have to be careful not to leave anything behind, but I've got a 2x times 2, which gives me 4x on the top, 1 times 1 on the bottom, so 4x over 1 is just 4. So there's my reduced question, my reduced polynomial multiplication. So I have multiplied them together, and what was left, I left out the x, so what was left was 4x. And my restriction is that y can't equal 0. Again, even though there's no y left at the end, I still have to write that restriction, because anywhere along the lines, if y equaled 0, I would have a division by 0 problem. If you got something that's more than a monomial, a binomial or a trinomial, it has to be in factored form. So these binomials, in this case, we got it in factored form. These ones, again, are monomials, so can't factor them. But I can only reduce things that are factored. Again, let's start with the restrictions. On the bottom here, if x equals 0, then I'm going to have division by 0. So x can't equal 0. For this one here, if x equals -3, we're going to have division by 0. So those would be my only restrictions I have to worry about. When I look to reduce, now that it's factored, this x plus 3 can cancel with this x plus 3. And the 4 can cancel or reduce with the 8, 1 and 2. The x's can cancel each other out. So what I've got left on the top is 5 times 1 times 1 times 1, or just 5. What I got on the bottom is 2 times 1 times 1, so 2. I could leave it like that. That's already in lowest terms. Yes, I could rewrite that as 2.5, but I don't need to. C part, we've got ourselves a binomial here and here, neither one of which is factored. So again, essential that we factor this before we start trying to reduce. So I'm also going to factor it before I try to do the restrictions as well, because, pardon me, once it's factored, then the restrictions are much easier. Now this and this, those are monomials, can't factor them, as I pointed out before. So I leave the 15y squared, but on the bottom, I can common factor out a 6, leaving me with y minus 4. On the top here, I can common factor out a 5, and I've got y minus 4 in the brackets again. Bottom can't be factored. Okay, now I can see what my restrictions are pretty easily. From this one, I can see that y cannot equal 4, because if y equals 4, I'm going to get 0 times 6, which is 0, and I'll have a division by 0 problem. This one's a monomial. We've seen that anytime it's a monomial, then the variable, if it equals 0, it's a problem. If y equals 0, 0 times 20 is 0, and we still have a problem. We have a division by 0 error. So there's the restrictions. Let's reduce. These binomials are obviously, it's possible to cancel them out. The y, I can cancel this y with one of the y's on the top. 5 goes into itself once and into 24 times. And how do you guess? Actually, I was going to say I'm done, but no. I can divide 6 by 3, and I can divide 15 by 3, and now I think I'm done. So on the top, if I multiply everything out, I get 5. On the bottom, I got 2 times 4 times 1, so I just got 8 on the bottom. So 5/8 is a fraction in lowest terms. That would be my answer for that one. So as far as multiplying rational expressions, rational functions, goes, no rational expressions, it's very similar to just simplifying. It's just that we've got two things multiplied together, and we can reduce anything on the top of either of the fractions with anything on the bottom of either of the fractions, as long as, you know what I'm going to say, I hope, it's in factored form. It has to be factored. Here's a more difficult looking one. Again, this is not factored. Absolutely have to factor it before I do anything. People who start crossing things out like, 2x squared and 4, I can just put, no, doesn't work, has to be factored. These are all trinomials, which can be factored using different factoring techniques. So if I start with this one, I'm just going to do a little trial and error. If I had 2x and, I'm going to do rough work over here, 2x and x, and 1 and 2 like this, I think that's going to work. I'll end up with 4x and 1x, which I can add together. So if I make everything positive, there's my two factors. So for the top, I've got 2x plus 1 and x plus 2. So there's my first one factored. For the next one, do trial and error again. And so for 4, maybe I'll just try doing 2x and 2x. Again, I like to take the factors that are closest together. So for 4, I could do 4 and 1 or 2 and 2. I'm going to go 2 and 2 because they're closest together. For 5, I can only do 5 and 1. If I cross multiply, so to speak, what I get is 10x and 2x. And if I were to subtract the 2x from the 10x, I would get this 8x that I want here in the middle. So I think we're good, especially when we realize that we want a negative 5, so one of our signs has to be negative. So if the 10 were negative, then negative 10 plus 2 would give me my negative 8. The 10 came from having the 5 be negative, so my two factors would be 2x minus 5 and 2x plus 1. So that's my second one. So you can see that this question is kind of a biggie, isn't it? Because I have to factor each and every one of these. So I'm just going to carry on for the next one, which was 2x squared minus 11x plus 15. I got 2x and 1x. And for 15, if I pick numbers that are close together, I might do 3 and 5 would probably make sense. Maybe if I put the 3 here and the 5 here, I think that looks promising as I think ahead a bit. 2x times 3 gives me 6x. 5 times 1x gives me 5x. That would add together to give me the negative, that would add together to give me 11, especially if both of these numbers were negative. So if I made this a negative 5 and a negative 3, when I multiply those together, I get the positive 15. So that looks good. I think we're on the right track. We'd have 2x minus 5 times x minus 3. And then I have to do it one more time for the bottom. And let's keep doing it over here on the left. So maybe I'll move a bit farther left. So for 3x squared, I could do 3x and 1x. And for the 2, I'd do 1 and 2 like this. I'd get 3x times 2 is 6x. 1x times 1 is 1x. When I add them together, I get 7x. So if I make everything positive, then it's going to work out. So 3x plus 1, 1x plus 2. And there, now I've fully factored it. That was a lot of work, but sometimes that's what we have to do. This would be a good place to stop and do my restrictions. So if 2x minus 5 equals 0, I'm going to get 0 on the bottom. So that would be if I had 5 over 2. And if you're having trouble seeing it, you can always set 2x minus 5 equal to 0 and then try solving it for x. But I'm going to get 5 over 2 when I do that. 2x plus 1, if I set that equal to 0, I'm going to end up with negative a half. 3x plus 1, if I set that equal to 0, I'm going to end up with negative a third. And x plus 2, if I set that equal to 0, then of course, if x equals negative 2, that also will be a restriction. So there's my 4 restrictions for this one. Now, I can cancel anything on the top of either of the fractions with anything on the bottom. So what have I got? Well, 2x plus 1 and 2x plus 1 can cancel out. 2x minus 5 and 2x minus 5 can cancel out. X plus 2 and x plus 2 can cancel out. All I'm left with is the x minus 3 over 3x plus 1, and I can't do anything else with that. So this is my reduced form of that multiplication. So a lot of factoring, a lot of reducing. Don't forget the restrictions. But it's, if you take your time and think it through carefully and make sure you follow the rules of math, it all works out. For example 3, now we're changing gears a bit. We're being given a function. F at x equals x squared minus 36 over 6x minus x squared. Find f at 1. Okay, so just going back to what we've done before, I'm going to put 1 in everywhere there's an x and see what I get. That gives me 1 minus 36 over 6 minus 1. So I end up with 35 over 5, which reduces to 7. What about when f at x equals, f at negative 2, when x equals negative 2? All right, if I put negative 2 in everywhere there's an x, okay, negative 2 squared is 4 minus 36 over negative 12 minus positive 4. That gives me negative 32 over negative 16, which equals positive 2. So we can plug numbers into these rational functions, just like we can plug them into any function using function notation. What values of x are not allowed? Well, that would be our restrictions again, right? When the denominator equals 0, the denominator was 6x minus x squared. If that equals 0, then we've got a problem. So I'll put a cannot equal 0. I should factor this. I can take an x out. So if x is a common factor, then what I've got is 6 minus x left in the brackets. So in that case, x can't equal 0, because if x equals 0, then 0 times the brackets will still equal 0. So that's one of my restrictions. and 6 minus x can't equal 0. So this is sort of reversed from the way we usually look at it. Usually it's x minus 6, in which case, we just read it a bit differently. But think about what value, if I put in for x, will cause it to equal 0. The answer is 6. If I put 6 in for x, then that whole bracket equals 0. And that would not be a good thing because that's part of our denominator. So these are the values of x that are not allowed. X cannot equal 0 and x cannot equal 6. So really it's just another way of asking the restrictions. So we just looked at multiplying. How is dividing different? Well, think about how dividing is different when we're dealing with numbers, with fraction numbers. When we divide a fraction by a fraction, we invert and multiply. We flip the second fraction and change the divide sign to a multiply sign. Exact same thing is going to happen for rational functions. The only difference in this case is that we have to think about our restrictions. So as you can see here, you have to state your restrictions for the top and the bottom of any rational expression that you flip. And the reason for that is because if you flip it, that means that both the top and the bottom have been on the bottom at some point, and then we're going to have a problem with division by 0. So aside from the flipping part, we have to be careful of restrictions. Here we are back to a monomial type question. So again, I can't factor it because they're monomials. It is division, so I will flip the fraction after the division sign upside down, change this to a multiply, and I can carry on from here. But as far as the restrictions go, I need to look at the 3 that was here, obviously no restriction from that, the 5 that was originally on the bottom, and the 6y that's currently on the bottom. The only thing that's going to give me a restriction is the 6y, isn't it? So from that, being a monomial, I know that if y equals 0, I'm going to have a problem because 6 times 0 would equal 0. I have division by 0. So my only restriction is that y can't equal 0. As far as simplifying goes, now that I've changed it to a multiply, I can reduce like I was just doing above. So 2 goes into 6 twice, 2 goes into 10 5 times, and there's nothing else that can be done here. 5 times 5 is 25, 3 times 2y is 6y, and that's as far as we can go for reducing that one. Here's a couple of binomials. So again, I will start by flipping it. Well, actually, I'll factor the first one since I can. X squared minus 4 factors to x minus 2 or plus 2, whichever you want to do first, and minus 2 times, flip it upside down, x plus 2 and x. So I flipped it and I changed it to a multiply. As far as the restrictions go, x cannot equal plus or minus 2 from that denominator there. So plus 2, minus 2. X cannot equal minus 2 from this denominator. It's really the same thing as before I flipped it. But I've already covered the minus 2, so I don't need to worry about writing it a second time. Nor can x equal 0 from that denominator there. So there's my restrictions. Okay, now we reduce. Now that it's factored, I can reduce anything, one thing on the top with anything on the bottom. And that's as far as I can go. So what's left on the top is 1 times 1, or 1. What's left on the bottom is 1 times x. So just 1 over x is what it reduces to. C part, now we got some trinomials and binomials. We're going to have to do some serious factoring in this case. So for the first one, before the divide sign, I don't have to flip it. I can just factor it. The factors for this would be x plus 2 and x plus 1. That would multiply to give 2 and add to give 1. Sorry, add to give 3. On the bottom, I can common factor out x squared. And what I'd be left with is x squared minus 4 inside the brackets. So that's going to be able to be factored more, but I'll do that in the next step. I'll flip the fraction that comes after the divide sign. And what I'll get is 5x cubed minus 9x squared minus 2x over x squared minus x minus 2. So there's the flip. Let's keep factoring. So I've already done the top of the first fraction. Nothing to do more there. In the bottom of the first fraction, I've got a difference of squares, which can be factored even more, can't it? So that can be factored down to x minus 2 and x plus 2. The top of the first fraction is a complex trinomial. So maybe, where will I do my rough work for that one? Maybe I'll do it up here. So again, I'll just do trial and error for 5. Oh, sorry, before I do that, maybe I'll have to do another step. I'm going to common factor out an x. Right, I can take an x out of every one of those terms. So I got x times 5x squared minus 9x minus 2. And then I'll be able to keep going with what's inside the brackets. But I'll save that for another step. On the bottom, two things that multiply to give negative 2 and add to give negative 1 would be x minus 2 and x plus 1. So finally, I have to keep factoring the top of the second fraction before I'm fully done. So just rewriting everything out again like I am here. But now that I'm at the top of the second fraction, I need to factor this. So this I will use my trial and error. So 5x can only come from doing 5x squared can only come from doing 5x times 1x. 2 can only go from 2 and 1. So if I multiply like this, I'd get 10x and 1x. That can give me the negative 9 I'm looking for, especially if the 10x is negative. So if I make this a negative 2, that'll give me negative 10x. Make this a plus 1, my factors would end up being 5x plus 1, and on the bottom would be x minus 2. And now I think I'm good to do my restrictions. Restrictions are going to come from anything on the bottom, but also the top of the second fraction because it started out on the bottom. Looks like I forgot to write down my second factor, didn't I? This should be an x. Sorry, I didn't forget to write it down. Just I've been doing so much, I wrote it in the wrong place. Let me backtrack for a second before I say what I need to say. All right, so the x minus 2 should have gone up here on the top. So I'm just going back to this, x minus 2. That was on the top. And then I should have written x minus 2 over x plus 1 on the bottom. Apologies. All right, such a long question. I guess my brain is starting to go into autopilot. But anyway, we're good to carry on now. Now I'll do the restrictions. Maybe I'll do them underneath here so as not to encroach on my space for part D. So the restrictions are going to come from anything in here, anything on here, but also anything on here because that top was originally on the bottom. So from this one, if x equals 0, we got a problem. From these two, it can't be at plus or minus 2. So it can't be 2 or negative 2. From this one, x can't equal 0, but that's already been covered off. From this one, x can't equal negative 1/5. And if you can't see that, set 5x plus 1 equal to 0 and solve it. You'll get negative 1/5. Plus 2, we've already got plus 2. Plus 2 again, already got that. My goodness, my iPad's starting to act up too. And the last one, x plus 1. All right, so from that one we get that x can't equal negative 1. So a whole laundry list of restrictions. Now let's get to the reducing part. I'm going to get rid of this highlighting for now, if I can, without erasing everything else. And come on. There we go. Put that back. All right, let's start reducing. Anything on the top, with anything on the bottom as long as they're the same. X minus 2 and x minus 2. These two can't cancel out because they're opposite signs. But I can reduce this x here with one of the x's and the x squared over there. And I think that's all I can do. So just going down here, I've got x plus 1 left. And I've got 5x plus 1 on the top of the second fraction. And I've got x from the first fraction. I still have that x there. And I've got x minus 2, and I've got x minus 1. So those are all the ones that were left from after the canceling was done. So sometimes we can't reduce it completely. We just reduce it as far as we can go. But that's it for that one. And the last example is meant to show how we can have multiple operations in a single simplification. So we got multiplying and dividing. We only flip the fractions that are immediately after the divide sign. These ones are all monomials. Every one of these is a monomial, which means that I can't common factor any of them. I do need to simplify this a little bit, though. Remember that 2x all squared means that I'm multiplying 2x times 2x, which is actually going to equal 4x squared once I expand it out. So let's do that at the same time that we flip. So I'm going to just rewrite this part. X squared over 2xy times y over 2x squared times, so I'll flip this upside down and I'll get x y squared over, as I just showed, it's going to be over 4x squared. So where are my restrictions going to come from? Denominator, denominator, and both the denominator and the numerator for this one because I flipped it. So my restrictions will be from this one, x can't equal 0 and y can't equal 0. Maybe I'll just do the x's first. So x can't equal 0. From this one, x still can't equal 0, but I've already covered that. From this one, x still can't equal 0. Already covered it. Now that I think about it, since they're all monomials, obviously it can only be 0. So x can't equal 0 is covered for all of them. And I'm going to find the same thing happens for the y's. Whether it's from here or here, y can't equal 0. So x can't equal 0, y can't equal 0. Those are my restrictions. And then as far as reducing goes, anything on the top with anything on the bottom, right? So I could reduce x squared and x squared. I could reduce y and y. There's no more y's on the bottom. There's no more x's. Oh, there is another x on the top. I could reduce x with one of the x's, maybe just this one here. So now there's no more x's or y's. No more y's on the bottom, no more x's on the top. So there's nothing left to reduce. There's no numbers on the top. So I got 1 times y squared on the top. I got 2 times 2x squared times 4 on the bottom, which gives me 16x squared. And that is as far as we can reduce that. So that is the last example. I just want to point out that what we've done here is really just an extension of what we did in the last lesson. If what I was doing with the reducing and the factoring and the restrictions was complicated for you, you might want to go back to the previous lesson, which was lesson 10, and just review the basics first, because you really need to know the basics before you can do the multiplying and dividing part.